Hello, everybody. Welcome to another workshop from our Block Magic Hackathon. Today, we're going to be exploring data feed on zkSync. And to help us to share a lot of nice stuff with us tonight, we have Valentina. Before that, just to remind you guys, leave your like and subscribe in the video. And just in case, if you are not subscribed in the hackathon, here is the link. Saying that, welcome, Valentina. Thank you for being with us. And it's all your stage. Introduce yourself and do your show.
Thank you. Do you want to throw up that screen there? Okay, cool. Sweet. Awesome. Thank you so much for the introduction, Jeff, and thank you all for joining me. And this is the final workshop of the Block Magic Hackathon. So if you've made it this far, then you are already a winner in my eyes. So congratulations. I am very excited to present to you our final discussion, and it's going to be on exploring data feeds on zkSync. So let's go ahead and hop on into it. So we are going to ultimately end up with a product. And in this case, that product is going to be a smart contract that we're going to deploy on zkSync that makes use of Chainlink data feeds, namely our price feeds, and it'll get on-chain pricing information for us. And you can start to think very early on how you can apply this information, the pricing information of the assets, so that you can make some DeFi magic happen. You can plug and play and use these pricing details in whatever way your heart so desires. So before we continue, allow for me to introduce myself. I'm Valentina Alexander, and I will be your guide today. I'm a developer relations engineer here at Chainlink Labs. I'm also a full stack developer. I have experience ranging from smart contract development in Solidity, machine learning in Python, web development in TypeScript, and I've also spent time building backends and vanilla JavaScript. So I've done quite a few things. I've been around the block, so to speak. But now that you know a little bit more about me, let's dive into the more interesting information, and that's today's workshop, where we came here for. So we have two main topics that we're going to be covering today. First and foremost, of course, Chainlink data feeds, no surprises there. And naturally, we're going to be linking that into the benefits of zkSync so you can see some of the value that is added whenever we explore this new technology, this emerging technology that we have here. So Chainlink data feeds, ultimately what they do and how they operate is they leverage Chainlink's DAWN, and DAWN is just an acronym that's short for the Decentralized Oracle Network. And we use Chainlink's DAWN to get manipulation-resistant data from external providers. So if you want to just think about that a little bit deeply, manipulation resistance is not just a word, it's actually a word with meaning. And manipulation resistance can be very impactful when it comes to certain utilities, such as being able to ensure, for example, your assets aren't being liquidated in a lending market because someone decided to manipulate the prices by changing the price on, let's say, a decentralized exchange by purchasing a bunch of that asset or selling a bunch of that asset or using like a flash loan, which is very popular nowadays with a lot of people who are trying to exploit protocols. So we see a lot of money that's lost whenever people don't take the time, energy, and effort to securely provide data. And it's extremely important, especially whenever that data that's being provided must be accurate and also be resistant to manipulation, because manipulation can ultimately make your information inaccurate. So the benefits of zkSync, we're also going to be exploring those, and we're going to end off everything by deploying a smart contract onto zkSync blockchain. So let's start off with covering what Chainlink's data feeds are and how you can leverage them to build a secure, decentralized finance application for your community. So there are many different types of data feeds that you can choose from. There are price and proof of reserve feeds, the rate and volatility feeds. We have L2 sequencer updater feeds as well. So the price feeds, what they do is they provided the real-time price for a given asset. No surprises there. However, this also includes the NFT floor price, which some people may not know. So the NFT floor price is very useful if, for example, you're trying to figure out what is the best price that I can get for a given NFT inside of a collection. Let's say that you like Bored Apes or something of that nature, and you want to see the best price that's out there, well, you can do that in a way that's, again, manipulation resistant, and it's a source of truth that you can rely on. We also have proof of reserve feeds. So these report the status of reserves for various assets. And as some of you may or may not know, this has become more in demand due to recent events that require protocols to actually prove that they're transparent and reliable in their asset management strategy. I'm not going to name names, but there are some headlines that have been made where people have lacked the proof of reserves that people are now starting to realize is actually very important to have. So Chainlink is there to be the solution and the provider of these sorts of pieces of information. Also, we have rate and volatility feeds. So these provide data on interest rates and asset price volatility. And finally, we have the L2 sequencer uptime feeds, and these track the uptime of L2 sequencers to manage risks like mass liquidation. So overall, Chainlink data feeds are composed of three main components. We have the consumer contract, we have a proxy contract, and we have an aggregator contract. So the consumer contract, those are used, they use data that's provided by the Chainlink feeds. The proxy contracts, those are effectively intermediaries. They fetch data from aggregator contracts with no downtime between upgrades. And that leads us to our final feed component, and that's the aggregator contracts. And those maintain and update the data provided to these smart contracts. So just like it sounds, they aggregate many different potential responses from the providers, and they find the median response for that. Now let's look into the benefits of zkSync. So we have 6 right here on our screen. We have cost, speed, scalability, security, UX, and also interoperability. So looking into cost, so it's very cost efficient. zkSync allows for transactions at a fraction of the cost of L1 blockchains. And according to my notes, it's also the cheapest of all of the L2s, or rather not the cheapest, but the lowest fees of all the L2s. Also extremely fast. So we're talking about very highly optimized virtual machine that is able to leverage Ethereum's decentralization while allowing for it to operate as a scaling solution. Transactions on zkSync are confirmed faster than on L1 blockchains, making it a suitable choice for applications where speed is crucial. We also have scalability. So as a L2 solution, zkSync can handle a higher number of transactions per second. In fact, 100 to 200 TPS per chain, and more than L1, making it much more scalable. Also, it has security. It maintains the same level of high level security because it actually inherits the security model of the underlying L1 blockchain. And the way that it does this is basically batching those transactions. It's not sending all of those transactions. And what it'll do is it'll get all the transactions. It will remove and reduce any sort of redundancy. So let's say Alice sends Bob 1 Ethereum. Bob later sends Alice 1 Ethereum. Well, it's just going to cancel each other out. They're just back at where they were. So it's not going to have any useful information to send over. This is also really useful for you having the ability to have a private layer as well, since those sorts of transactions are covered, and also allows for you to do things like high volume trading, etc., in a manner that is very quick and very easy, and also maintaining a very low cost. So it's very low cost as well. Also, it's very user-friendly. So zkSync is designed to be easy to use. For example, it has an integrated development environment, an IDE that's similar to Remix. We're going to be exploring that. It's called Atlas, and it's actually very, very neat. One neat thing that I noticed on there is it allows for you to use machine learning. It's already integrated in there. So you can just type in there and say, hey, I want you to make me a smart contract that gives me a price that is tamper resistant and is able to tell me the price of Ethereum, for example. Or you can stay tuned and we can learn how to do it ourselves and not have to rely on an artificial intelligence. But it's nice to be able to have that option in your card of tricks, so to speak. So it's really user friendly. It's compared to Remix, especially, you're going to see some nice upgrades there. And then finally, interoperability. So zkSync is compatible with Ethereum. Which is one of the most widely used L1 blockchains. I think it's actually the most used L1 blockchain, allowing for easy integration with existing Ethereum-based applications or EVMs. So what we're going to do is I'm going to first and foremost allow for any of you to ask any questions while I transition this from the slides over into the next layer, which is going to be going into the actual code that we're going to be playing around with. I hope that you have some more clarity into zkSync, also some more clarity into Chainlink's data feeds, so that you can start to get the gears turning in terms of how you can work out some block magic of your very own. So what we're going to do next is we're going to connect to Atlas and deploy a price feed of our own, and we're going to get the price of ETH, and we're going to report it on chain in our own smart contract. So after you get this code, you can take it and make it into your very own. In fact, challenge yourself to get a response on Atlas yourself, and maybe even change some of the configurations. And whenever we get to that part, I'll tell you some of the configurations that you could potentially change. So once you feel confident and you feel comfortable, you can move on into the big leagues and actually use our price feeds, Chainlink's price feeds, on zkSync in production. So also, if you're interested in following me and continuing your learning path in Web3 developments, you can visit zeroxbuns.com. And also on the website, you can find links to subscribe to me on YouTube and on Twitter or X at 0xbuns, or read my articles, etc. You'll also find that in the description of this YouTube video. So let's transition over, and I'm going to see if there are any questions here. I like to lean. Let's learn about data feeds and zkSync. Yes, yes. Yes, it is EVM compatible. Greetings, Christopher. Okay, so I'm going to go ahead and change this up. Let's see, we're going to start off with the faucets. So what we're going to do here, I'm sharing with you all the faucet, and you're going to need to have this information because the faucet is actually a very useful tool for us today. So now that we have an idea of how Chainlink data feeds operate, we're going to perform some block magic together. We are going to deploy our very own smart contract. And this contract is what we refer to as a consumer contract, which will enable us to acquire the price of an asset in USD. In our case, it's going to be Ethereum. So our feeds allow for your DApp to take advantage of, if you recall, a manipulation resistant price. And your reference price will be powered by Chainlink's decentralized Oracle network, or DAWN. And this provides assurance and peace of mind. So your community will appreciate you choosing a solution with a track record of success. And if you don't have a community, think of your community as yourself. Give yourself a pat on the back because you're doing yourself a good service by using a great one. So we have enabled, Chainlink has enabled over $10 trillion, that's with a T, in transactional value over the years. And a fun fact, we actually went live with our first data feed 5 years ago this month in May of 2019. So enough about that. Let's hop on into our live demonstration. If you see the page that we're looking at right now, that's faucets.chain.link. Once you're signed up and logged into there, what you're able to do is connect your GitHub account, and then you'll enter your wallet address, and then you'll select ETH so that you can get your test ETH. Make sure that you're connected to zkSync Sepolia testnet, and you will be able to verify that you're human. Hopefully you are, and hopefully you can verify that. Sometimes it could be tricky to verify if you're a human, but once you get there, you can click send request and it'll give you some of those testnet tokens. I already have some, so I'm not going to be greedy and take more than I need. And let's move on to the next layer, which is going to be looking at Atlas. So the way that you're going to get to this next layer, the links, yes, they are available, Christopher. You can find them in the description of this video. And I made it very easy for you all. So the way that this is set up is Atlas. For you to see this page here for the consumer contract, what you'll do is you will go to zkprice.link. So that's zkprice.link. Whenever you go to zkprice.link, that will open up the project via the Atlas IDE. So that was the integrated development environment that I was referring to earlier. That's like a remix, but it's for zkSync. And I think it's absolutely awesome. As you can see here, there's Atlas Copilot, which is that AI configuration that I told you about earlier. What you're going to want to do, and what I've already done, is connect your wallet and also select your network. In this instance, for this demonstration, we're going to be using zkSync Sepolia testnet. And it's important that you take note of the network that you're using because we're going to need that information whenever we deploy the contract. We're going to make sure that our contract is set up correctly. Speaking of which, once you're there at zkprice.link, That's zkprice.link. You're going to open up the contract by navigating to contract and then going inside the contract directory. There's a smart contract called dataconsumer.sol, and that's short for Solidity. And let's look at the architecture of that smart contract so you can better understand what's going on under the hood. It may look pretty simple, and it just might be, but for some of us that aren't too familiar with things like an interface and what it means to declare something as in a constructor and use that element of the interface to interact on, this will be very enlightening for you all, hopefully. So what we do in the very beginning of the contract is we actually import aggregator v3 interface from the Chainlink contracts library, and we use this to interact with the Chainlink price feed oracle. So this is a standard that we just use across the board whenever it comes to what we're expecting every aggregator to inherit. So we declare the data feed variable of type aggregator v3 interface, and this stores the reference to the Chainlink ETH USD price feed that we're going to be referring to later on. So you can see here, data feed, aggregator v3 interface. It's the contract originates over here from our Chainlink repository. And you can see here, we're creating and initializing that data feed instance. And this is what I was mentioning earlier. You want to pay attention to the contract address that you're using, and you want to make sure that the contract that you're using actually aligns with the contract that the network to which you're deployed, as well as the address that is associated with the price feed that you're looking for. So some of you might be wondering, how do I get the right price feed? Well, I'm glad that you asked. The way that you do that is you're going to want to go to our docs. So let me demonstrate that to you. So once you go to docs.chain.link, and that's also in the description, you'll see that there's a few options here. It may change in the future, but for now, we have 6 products that are listed here. Hovering over them shows you the chains that are supported. I think that's a really neat feature because you can see very quickly and easily what chains you can use. So here we have a lot of chains. Data feeds, one of our original products here. Price feeds, you can see zkSync is there. So we're going to go ahead and click on data feeds. Once you're there on data feeds, you'll see here on the left side, you have feed addresses. So you want to click on feed addresses. And once you're at feed addresses, it says price feed addresses. Click on that. That will take you to this page. And here on this page, you have some information about the price feeds. And what we're going to be looking at here is networks. In our case, we're going to be using zkSync. Let's go ahead and click that. And if you're here, this means that you either followed along with what I just demonstrated, or you click the link in the description, which will take you right here. But it's very important that you take note of the difference between zkSync era mainnet, which is mainnet, versus the testnet, which is testnet. So we found testnet. Congrats. Another pat on the back. And we can see the pairs in the address and info. Here, the pairs that we're going to be using in this instance is ETH USD. And this just means that we're looking for the price of Ethereum referenced in terms of US dollars. So for example, you could think of ETH in terms of US dollars is just like saying how many US dollars per Ethereum. I mean, yes. So if Ethereum is $100, guess what? The response would be showing you something that resembles $100. It's going to be not exactly 100, and I'll tell you more about that in a second. Now let's go right back to where we were before, and that is our Atlas page. All right, welcome back. We're back on Atlas. So we have here, and it's very important again to verify that. Here we have the Sepolia testnet set up. That address that we're looking for is the ETH USD aggregator, and that is what we do in our constructor. We're just comparing and using those 2 pieces of information. Now what we're going to do is we're going to look at the components of the smart contract for get Chainlink data feed latest answer. So with get Chainlink data feed latest answer, what that does is it retrieves the latest ETH price from the Chainlink price feed. And inside of the function, we call latest round data. That function of the price feed gets you the latest price data. And what we do is we extract the answer value from the return tuple using destructuring assignment. So what does that mean? It's a kind of weird way to say that what we're doing is this information ordinarily would give us other pieces of information, but we're not interested in that information. However, we are interested in these commas because the ordering matters. It's commented out because we're not using the information, but it is information that you may want to use or you may just want to know. So it's commented out so that you're able to have the flexibility to amend this at your will. So we're only interested in the answer, so we commented out everything else, but you get the round ID, which is important because you may want to know like when was this last checked, and if there's a more recent round ID versus an older round ID, where it started at, the time set, the answered in round as well. And you can see the types here is declared right before that. You have uints and ints. So it's always going to be an int. You don't have negative prices, so it makes sense for it to be an integer, not an unsigned integer. So we have answer, and the answer comes from using that data feed object that we instantiated here in the constructor as an aggregator v3 interface. The interface allows for you to call a function called latest round data, and it returns here answer. So that might have sounded a little bit redundant for some people, but I just really want to make sure that we hammer home the concept here that we're getting back only one piece of information whenever we're calling the latest round data, but we could get other pieces of information. And that piece of information that we're getting in this case is simply the price. So now let's see what that looks like whenever we put that into action. What we're going to do now is we're going to proceed with deploying this contract. And this will allow for us to go ahead and check the actual price of the asset that we're looking for, which in this case is Ethereum. So what you'll do is you'll find on the right side, there is the option to select a file. You're just going to stay here with dataconsumer.sol. And then what you'll do is click deploy. It will load, and then it will ask for you to sign a message. Go ahead and sign that message. Wow, that was extremely fast. But no surprises there, right? Because it's extremely fast whenever we're using zkSync, even in testnet. So here we have two pieces of information that we get returned to us. We have the contract balance, as well as that really long function here, get Chainlink Data Feeds latest answer. And it looks like a funny number. It's like a really big number, but let's copy that. Let's see what it looks like. All right, so this number might not seem very informational, but in our instance, the way that we're actually reporting back these prices for the Chainlink price feeds is Solidity doesn't allow for you to use decimals. So what we're going to do is we're going to use the decimals that are implied here, and you can find out that information by just looking into the actual smart contracts themselves. And the way that we do it here is there's 8 decimals. So let's see, 1, 2, 3, 4, 1, 2, 3, 4. All right. So this is the number in USD. It's like this, right? It's a weird number because you're usually used to numbers like this, but we want to have some further levels of specificity. Because, for example, some tokens may be like worth 0.0000001, like a lot of like meme tokens, for example. But Ethereum, it's not a meme. It's 3084 is what it's returning here. Now, what we have in crypto, we say trust but verify, right? So what we're going to do is we're going to trust, but we're going to verify. And what we're going to do to verify in this case is we're going to see here. I'm looking at CoinGecko, and let's go ahead and refresh this. 3087.21. So remember, we're doing the median price. So we have CoinGecko's reporting prices that's getting from multiple different markets. We have CoinMarketCap that's reporting multiple different prices, right? So you can see there are many different prices here, some that are higher, some that are lower. In fact, there's 276 pages of them. Chainlink does something similar where there's a bunch of responses that are being given in these price feeds. And what we're doing is we're getting the median response, and that's what's being reported back to us. And in our instance, the price that was reported back to us is the 3084 price. So there we go. What we've done is we were able to successfully identify what we needed in terms of the constructor variable, which is the key piece of information that you're going to configure if and whenever you get this contract and make it into your very own. So I hope that this provides you with plenty of information to get you started and hopefully getting the ball rolling internally for you to think about how you can use and make use of Chainlink's price feeds in order to do some block magic of your very own. Thank you so much. See if there's any questions. What IDE are we using? In our case, the IDE that we're using is Atlas. And if you want to go over to the project itself, what you'll do is you'll go to zkprice.link. Of course, I'm glad I could be of assistance. And if you want to ask any more questions, feel free to tag me on X or Twitter or whatever it might be in the future, or find me wherever else you can find me. Just not at my house, please. Is there Atlas for other networks to do? Yes. So while you're in Atlas, you'll actually be able to see that there are other networks that you can use to connect with. I really do think that's a very exciting tool. I'm glad that I discovered it.
All right. Valentina, what an amazing class. Thank you.
Thank you.
Thank you so much for being here with us. Guys, it's still in time. If you still have any question, just leave in the chat and we're going to be happy to have a look on it. In case it not, remember to leave your like and to subscribe on our YouTube channel. And looks like we are getting close to the end. It's, as Valentina mentioned before, it's our last hackathon. Sorry, it's our last workshop. Please, not our last hackathon. No way to be.
Yeah, I'm like, wait, hold on. It's definitely not the last hackathon.
No way. It's our last workshop from this Block Magic hackathon. And before leaving you guys, I need to bring to the stage someone that organized everything for us. Sophia is this person, and if someone is responsible for putting together all this workshop with a lot of good people and great content, this person is named Sophia. So I would like to say thank you, Sophia, for your hard work and for these beautiful workshop sessions that we had along the last weeks. Please share some words with the community.
Thank you, Jeff. Happy. It's always a pleasure to put together this, all of these hackathons. And I definitely don't do it alone. It's a huge team effort, from everyone in Chainlink Labs. Like, for example, I may just schedule the session and get Valentina here, but she's the one behind the whole content. So I also want to thank to every speaker that took their time to come in this past 2 weeks. And I hope every one of you was actually able to learn something. And again, if you need all of the workshops that we had in the past 2 weeks, they are all in our YouTube channel, in Chainlink's YouTube channel. There's already a playlist called Block Magic Hackathon. So go there, watch and rewatch as many times as you need. We are almost Sunday, you'll be 2 weeks away from the deadline, which is crazy. Time definitely flies by.
Yeah. Right.
It's crazy. It seems like we started yesterday, Block Magic, but definitely take these last 2 weeks to rewatch all of these workshops that everyone put together, and do take the opportunity and advantages of our Discord office hours that will start seriously next week. So until, I believe the last one is May 30th, but if you go to hack.chain.link, you definitely can see the full schedule, and you'll see all of the office hours that we have scheduled. Valentina will be doing one as well in the last week. So yeah, hop on our Discord server. You'll see the office hours voice channel whenever someone is on. And again, if you have any questions, our whole team is on Discord. Ping your questions away. Someone will support you. And yeah, thank you for participating. If you haven't done so, do go register yourself in DevPost. You need to register in DevPost and in the Hackathon website, so hack.chain.link to be eligible. You need to be on both. And also a thank you to Jeff for being here and taking the time to help as well. Thanks again, Valentina. This was wonderful. And yeah, we are wrapping up the workshop season. And now it's really time to get hands-on and build those projects. We are so excited to see what you build. So thanks again, everyone.
Thank you, guys. So
Please
that's
submit
it.
your hackathon projects. It's important. Even if you think that it's not the best thing in the world, it's the best thing in the world that you participate. So you can do it. And we're here to help as well. We have office hours too.
That's it, guys. Thank you all in the chat as well, Jetta, Christopher. Thank you, guys. And see you all around.
Bye, everyone.
Bye. Thank you.